Let's get started with this week's information. Lots and lots of definitions, which is not the most interesting part of statistics, so hopefully we'll get most of them done the first week. So let's go ahead and get started. We're going to be talking about descriptive statistics. I'm going to move my head where it's not in the way. And when we talk about descriptive statistics, we are just taking that raw data and displaying it so we can see what it is. We aren't thinking about what probability something might happen later or anything like that. We're not inferring anything from it. So we have descriptive statistics, and it could be something as simple as just taking a poll, right? How many hours do you sleep at night? This is a simple dot plot where we would have 5 here, 5.5 here, 6 here. I can even make little marks. So this is a 5, woo, and this is 5.5. This is 6, and so forth. And this is our data, and we are simply just looking at the data and putting a dot wherever that data lies so we can see, oh, okay, right here in this middle, not really middle, but right here is where we have more people. So if this is 5, 5.5, 6, 6.5 hours of sleep is the most. We have a largest group getting that much sleep, not the most hours of sleep. But this is just data, and it's descriptive because we are simply showing what it looks like. Inferential statistics is where we're going to go the next step, and after we've studied the probability and some probability distributions, which come later on in the course, then we're going to use some methods for drawing these inferences, these conclusions. Is this good data? Is it not? And what can we predict about the future? And that's really where the fun of statistics comes in. And we just start enjoying that this term when we have to stop. So that's unfortunate. Statistics is based on probability. So if you like odds and understand probability and did well in those subjects, if you had some experience with those in other math classes, you might find this part of the course kind of easy. I think probability is very interesting. There's lots to it, and we use it every day, and you hear a lot of probability mentioned in news and other reports, and it is maybe not always accurate. So it's good to have a basic understanding of it so we can weed out good data, good statistics, bad statistics. Statistics, you're going to hear the word population a lot. You probably know what that means, but let's just look at an example of what that means. Here we're going to be talking, and we're going to use the same example on many terms that we're going to be defining. We're going to talk about, we want to know the average amount of money for a first-year college student that they spend at a certain college on school supplies, not including books. So we randomly survey 100 first-year students at the college. 3 of those students spend 150, 200, and 225 respectively. The population, what we're studying, is all the first-year students attending this school. So that's how we use that word population. If we are studying all freshmen, then the population is all the freshmen. A sample, then, is not going to be the entire population. We're selecting a sample because sometimes populations are too large and cumbersome, too expensive to poll and to get all those results. So using that same example, the sample would be all the students enrolled in one section, maybe all the students that come to eat on a certain day in the cafeteria, but we would take a sample of those students to look at how much they spent. A sample is not the whole. A parameter is something that we're going to use, and I think the best way to show that is just, let's look at the example that we've been using, right? Where we have this college and we were taking this sample. Well, the parameter is going to be the average or mean amount of money spent, including books, of the first-year college students at this time. We are using that number as the parameter, okay? We want to be able to maybe even do a sample. If we did a sample and we got the mean of the sample, then that would be the parameter as well. It just means a piece of the puzzle. Hopefully that makes some sense. A statistic is a number that represents a property of the sample. So we can talk about one math class. It is a sample of the whole population of math classes. And the average number of points earned by a student in that one math class is an example of a statistic. It's the little teeny piece of data. There's a little bit of an explanation for that. Variables, we use the word a little bit differently in statistics than we do in algebra. Variable, again, we're usually write X, Y, and Z. It is what we're looking at. It's not necessarily what variable are we trying to solve for, like in algebra, but it is a piece of interest that could change. Here we have that same example of our college students and what they're spending. The variable could be the amount of money spent, meaning we might be looking at that piece. It also might be how many times they go to the cafeteria. We can look at any piece and call it a variable. So it's just where we're focusing our attention. Variables can be numerical, as they are in algebra, or they can be categorical. Not all data is going to be numeric data. In statistics, we have the quantitative and qualitative, which I think the next set of slides talks about a little bit. Data are the actual values of these variables. They may be numbers or they may be words, which is kind of a new thought. And the data is the plural. Datum is actually the singular little piece of data. So looking at that same example, the data are the dollar amount spent. So you would have a whole list of the numbers. Each one of those would be a datum that creates that data set. So we'll be talking a lot about data sets. Lots of definitions, and maybe some that you're familiar with, but hopefully they won't give you any trouble. Thanks.